In this example, we will create a sheet metal bracket in ZW3D using the sheet metal features. First, we launch ZW3D and create a new part file. After that, we switch to the Sheet Metal Ribbon tab and rename the part to Bracket. In the feature history, we double-click the Sheet Metal feature to edit the global parameters. We set the bend radius to 1 mm. Under Flange Parameters, we set the material position to Material Inside and change the default flange length to 25 mm. Next, we set the K factor to 0.45. For relief, we select Rectangle and set the relief width ratio to 0.5. Then, we validate the settings. To create the base feature, we start a new sketch on the top plane. Using the Center Rectangle tool, we draw a rectangle from the origin. We double-click the default dimensions and change them to 50 mm and 100 mm. At this stage, we draw additional lines to complete the base shape. Using Power Trim, we remove the unnecessary lines inside the sketch. Then, we select the two side lines and apply an equal length. Using Quick Dimension, we set the length of one line to 30 mm. Next, we select the line that is equal to the others and select the coordinate system Y direction. We set the distance to 70 mm. The sketch is now well defined. We exit the sketch. From the Manager tab, we select View and switch to Isometric View, or we press Ctrl+I. We proceed by launching the Extrude tab command and selecting the sketch. We reverse the thickness direction and validate the feature. To create the first flange, we select Flange with Profile from the Sheet Metal Ribbon toolbar. We select the edge and edit the profile sketch. Using Quick Dimension, we set the flange length to 25 mm. Then, we add an arc. We select the connecting line, right-click, and choose Toggle to convert it into a construction line. Then, we exit the sketch. Once done, we select Mirror feature. We choose the Flange feature and select the coordinate system YZ plane as the mirror plane. Then, we validate. We double-click the left mouse button to fit the model in the graphics area. At this stage, we select Dimple and choose Flared Hole. We select the face, right-click, and choose Sketch. We draw a circle and set its diameter to 12.7 mm. Then, we exit the sketch. The dimple feature is created automatically. We adjust the required parameters and validate. Now, instead of creating a sketch first, we start the Extrude command directly. We right-click and choose Sketch. Then, we select the face. Using the Center Slot Arc tool, we create a slot. First, we select the center of the circular feature. Then, we define the first and second slot centers. We set the slot radius to 1.5 mm and validate. After that, we set the distance between the slot and the dimple to 15 mm. We remove the unnecessary dimension. Using Quick Dimension, we select the two slot centers and set the center distance to 10 mm. Next, we draw a line between the slot center and the dimple center. We right-click and choose Toggle to convert it into a construction line. Using Quick Dimension, we set the angle between this line and the coordinate system Z direction to 45 degrees. Then, we exit the sketch. In the Boolean shape options, we select Remove. We reverse the direction and validate. Once this is done, we create a circular pattern. From the Sheet Metal Ribbon toolbar, we select Pattern and choose Circular Pattern. We select the slot as the base feature. For the direction, we select the circular edge of the dimple. Under Mode, we choose Number and Range. Then, we set the number of instances to 4. The next step is to return to the mirrored flange and create a vent. In ZW3D, the vent sketch must be created manually. We start a new sketch and draw 4 circles. Then, we apply the required diameter dimensions. We now draw a line. From the Sketch toolbar, we select Basic Editing and choose Pattern. We set the pattern type to Circular Pattern. We select the line as the base entity and the circle center as the pattern center. Then, we set the number of patterned lines to 3. We exit the sketch. From here, we select Vent from the Sheet Metal Ribbon toolbar. We select the flange face. For the sketch boundary, we select the large outer circle. For the ribs, we select the lines and inner circles. For the fill boundary, we select the small center circle. Then we validate. In the feature history, we hide the vent sketch. The vent feature is now complete. We then add 2 chamfers to the corners of the base plate. We select the extrude feature and double-click to reopen the sketch. Using the center rectangle tool, we draw a rectangle and apply the required dimensions. We reverse the direction if needed. The Boolean shape option is already set to remove by default. To create the next cutout, we start the Extrude tab command again. In the Profile section, we right-click and choose Sketch. We draw a corner rectangle and apply the dimensions. After that, we add an arc. We select the connecting line and choose Toggle to convert it into a construction line. We continue applying dimensions until the sketch becomes fully defined. Using mirror entities, we mirror the sketch geometry. Then we exit the sketch. We enable Merge with Base and Validate. To create the bends, we select Fold by Line. We right-click and choose Sketch. Then we draw a line and set the required dimension to fully constrain it. ZW3D shows a loop warning on exit. We select Yes to continue. We then select the face. Under Flange Parameters, we set the material position to Inside and Validate. We repeat the same workflow to create another fold line. This allows us to reverse the bend orientation and ensure the flange is formed in the correct direction. This time, we enable Flip Bend Direction before validating. As we can see, the bends are now created correctly. For the opposite flange, we repeat the same bend process using the same fold-by-line workflow, applying the same sketching and feature creation steps to maintain symmetry and ensure both flanges are consistent with the design. Since this bend cannot be mirrored, we create it manually. As we can see, the bends match the sheet metal example. Using the keyboard shortcut Z, we launch the Hole command. To locate the center of the arc, we hover over the arc, and the center point appears automatically. We place the hole at this location. We then create a second hole on the opposite side. We set the diameter to 7 millimeters and define the end condition as Through All. Now we will create a punch feature. We select Punch from File and open the Bridge Lance file. For the location type, we choose Constraint. First, we select the base face. Then, we define the positioning by selecting a face on the bridge lance as the first entity and a face on the base feature as the second entity. We set the Z-coordinate location to 2 millimeters. After that, we apply an offset of 15 millimeters. Under the Open O tab, we select the 2 side faces of the bridge lance. These faces are automatically removed from the punch shape. We create a second punch using the same workflow. For this punch, we set the offset value to 2.5 millimeters. Again, under the Open O tab, we select the 2 side faces of the bridge lance, which are automatically removed from the punch geometry. Using the Z shortcut, we launch the Hole command again. We set the hole diameter to 4 millimeters. To position the hole, we right-click and choose Between. We select point 1 and point 2. The hole is automatically placed at the midpoint. We repeat the same process for the second hole and set both holes to Through All. We proceed by creating a partial flange. We select the edge and set the start value to 0 millimeters and the width to 10 millimeters. For the flange parameters, we keep the material position set to Inside. We change the bend height to 20 millimeters. Then, we set the length type to Outer Height and Validate. After that, we create a flange with Profile. We select the edge and enable Flip Flange. We then edit the profile sketch and set the profile length to 10 millimeters. Next, we add an arc and convert the connecting line into a construction line using Toggle. We continue by adding a circle with a diameter of 5 millimeters to complete the profile definition. Exit, then we validate the sketch. Now, we mirror this flange using the Mirror feature. We select the partial flange and choose the coordinate system YZ plane as the mirror plane. Then we validate, and the mirrored geometry is created successfully. For the next cutout, we start the Extrude tab command. We right-click and choose Sketch. To adjust the view, we apply Auto Align from the View menu or press F9. Using the Corner Rectangle tool, we create a rectangle and apply the required dimensions. We then add an arc and convert the connecting line into a construction line. The sketch is still underdefined. To fully constrain it, we select 2 points and apply an aligned horizontal in Y constraint. Then we add a circle with a diameter of 6 millimeters and adjust the remaining dimensions. The sketch is now well defined. We exit the sketch and complete the extrude feature. To create the jog, we select Jog from the sheet metal toolbar and start a sketch. Then we select the face. We draw a line, apply the required dimension, and exit the sketch. We then select the face. Under flange parameters, we set the height type to outside and the height to 13 millimeters. In the bend parameters, we choose material inside for the position. Then we validate the feature. We apply the required 2 chamfers to the selected edges, ensuring proper edge finishing, and validate the feature. To finish the model, we select Flatten. We choose the stationary face. Then we set the Z direction to 1 and enter an offset value of 50 millimeters. If we enable Flat Solid in the feature history, the flattened model appears above the bracket. If we change the Z direction to -1, the flattened model appears below the bracket. Finally, we enable Flat Pattern and hide the solid bracket. As we can see, the completed flat pattern is now displayed and clearly shows the bend directions. Thanks for watching.